So we got term 5, the danger zone for year 7, and we started off with food chains in lesson 1. And as we can see, this shows what organism is eating what. Energy flows this way. And again, we need to say that only around 10% of the energy is actually passed on, 90% is lost. So the shorter the food chain, the better. So we got grass, which is a producer. A producer is an organism that converts sunlight into its own food. So it makes its own food. Photosynthesis is the key there. We've got the grasshopper, which is a primary consumer. Consumer eats other producers. So it needs to have a producer. It's often a herbivore and will only eat plants. A secondary consumer, such as this frog, then is often called a carnivore because it only eats meat. And then we've got the python, which is the tertiary consumer, the last in the food chain. It's probably going to eat both, which we call an omnivore. This led us nicely into lesson 2, which is food webs. And this is just an upscale version of a food chain. But we can see the carp here has got an option to either eat algae or waterweed. And again, it just shows the relationship and who's feeding on what. Often though, if you remove one of these organisms, other organisms will either grow in numbers in populations or decrease in populations, depending on whether it's got other food available to it. More on that in year 8. Lesson 3 was on microorganisms, and at this point all you need to know is about these 3, and we need to be able to describe them. So bacteria are small, they're single cell, which means they're only one cell, and they're found in soil, air and food. That's all you need to know about bacteria at this stage. Whereas a virus, we need to know that it can reproduce in a host, such as us, a living thing, and it has a protective protein coat. Fungi are multicellular, so many cells, not single, multicellular, and they can vary in size. Lesson 4 was on water treatment. How do we get our water clean? Well, there's 3 main stages. We've got sedimentation, we've got filtration, and we've got chlorination. Now, sedimentation is when we leave it settle, and then all the solid particles are going to fall to the bottom under the force of gravity. Now, filtration is where we filter it. And then chlorination, we can kill bacteria. Lesson 5 was on climate change. So why is it important to reduce our energy? Well, more energy means more pollution because there's going to be more factories burning fuel, releasing pollution into the atmosphere. More pollution means more greenhouse gases, and it's going to create that global greenhouse effect there. It's going to stop heat being released from our atmosphere. So in turn, everything's going to warm up, and because it's warming up, these ice caps are melting. How can we reduce this? Let's reduce transportation emissions and let's reduce our energy consumption. Lesson 6 was on radiation. There's 3 different types. There's alpha, there's beta, and there's gamma, and these are the symbols that's used to represent them. Now, alpha is very low penetrating, meaning it doesn't go through paper or skin, it's stopped. Therefore, it's fairly safe. But if it does enter your skin, it's very ionizing, it's very damaging. Not good for you. It's a good job then our skin blocks it. Beta is the one that's in the middle. It can penetrate through our skin. It's only stopped by aluminium. And it's quite ionizing, so quite dangerous. We need to stay away from beta. Gamma, on the other hand, very penetrating. Thick lead is used to stop it, but it's got a low ionization, which means it does a little bit less damage. These things are 2 protons, 2 neutrons. We say that this is a helium nucleus. This is a fast-moving electron, and this is a high-energy electromagnetic wave. And that's radiation. Then we came on to half-life, and this is something you're going to have to practice in class. But really the definition of half-life is the time taken for a radioactive element's mass to decay by half. A mouthful, I know. So what's going to happen is you're going to have full sample, and then after one half-life it's going to decay by half. So you're going to lose half of it, and then after another half-life you're going to lose another half, and then another half, and then another half, and then another half, and so on and so on. Density was our last lesson in this term. Again, another familiar triangle. We've got M represents mass, we've got P represents density. This should be the letter rho, but we'll just use P. And then V for volume. Volume is measured in meters cubed, and density is kilograms per meter cubed. And again, I cover my finger on the letter that I want to measure. So if I'm looking for mass, it's going to be P times volume. And that was term 5.